Hey everybody, sorry it's been a week since I've been able to make a video. I've actually been on vacation, which was nice to get away for a little bit, take a week off with the family, but now back to work, and we have some piles of boards to catch up on, so plenty of work to do, and also plenty of videos we can make, hopefully to get caught up on, where we missed out throughout the last week. First of all, I was going to look at this board with you guys. This is a 12-inch MacBook. This is the 2007 model, or 2017 model, sorry. 820-00687. And this customer had mentioned that it was working perfectly until he had VirtualBox open, flipped the lid shut to put it to sleep, connected it to the power adapter, the USB-C adapter, came back a few hours later and it was extremely hot. None of the buttons would turn it back on. It had no power, but it was getting extremely hot. And he has some data on here that he wants off. As you all know, that the storage is soldered onto the board on these. So no power means no data. You've lost your data. So feel bad for this customer. Hopefully we can get this fixed so he can get his data back. So he sent it to us to get a logic board repair and hope to recover the data when he gets it back. He said when you plug it in, it immediately gets hot. So we're going to look at that. Now I don't know how this is going to turn out. I'm still learning on these boards. There's a lot of new things, the way the schematics are laid out, the way things are named on the schematics, all different. So it's a lot of it is new to me. So we're just gonna, what I'm gonna do, he said it gets hot when you plug it in, as soon as you turn it on. So let's see. Power adapter, or the plug for the USB-C. We'll plug that in. Show you what I'm doing here. Alright, so I have the USB-C flex cable plugged into the board, and let's just plug in our adapter, see if what kind of voltage we get, what kind of current we get. Okay, it's turning on. 1.45 amps, 1.43 amps, that's good. 19.7 volts going in, so that's correct. And yes, it is getting hot. Ooh, very hot. Not sure. Whoa. Okay. Well, let me unplug that for a moment. I don't want it to get hot like that for too long. Let's look at it under the microscope. See what we can look at. It's around in this area where it's getting hot. And right now I can see that this coil is kind of darkened in color. And typically that happens because of heat or a short. So let's look at that under the microscope and see what we can figure out. Make sure you're focused. And that is focused for me. It is for you too. Okay, cool. Alright, so we can see right away that this coil is a different color. That's weird. Just a second. Oh, let me fix my camera view here. This is weird. I updated to Mojave on my Mac, and so I'm having a little bit of issues with my broadcaster. Let me see if I can get this looking a little bit better for you. Okay. Alright, you probably have a bigger field of view now. Alright, so there is our coil that is changed in color here. And so I'm guessing that this is shorted to ground, not this coil, because neither side of the coil is ground. It's a line through. So first of all, let's check and see what we get. Let me turn on. Let's see, how do I do this? There we go. There, okay. Let me get you looking at the multimeter. Put that in resistance mode. Okay. And let's see if we're shorted to ground. I'm going to put the red probe on ground, which is just like this here, which is like a screw hole. And the gold part or the copper part there, that's ground. So I'm going to put the red probe on that. And now let's touch one side of the coil here. And you can see that that is shorted to ground. 0.004 is definitely there's no resistance to ground there. So this is shorted to ground. Alright, so let's look at the board view and see what that is. Sorry, I moved that. Guess you don't really need that right now. Alright, let's look at the board view. Here's the board. Okay. And let me add a view here for you. Maybe you can see the microscope. Oh, I think I have a... There we go. So we have the microscope view, this, and the board view. Okay, that's cool. Alright, so let me get this where you can see the whole board. Alright, that works. There we go. Alright, and so we're looking at this coil here, which is on the other side of the board. Let me see if I can get this. Alright, so on the other side of the board, and this coil right here, short of the ground, which is going to be, it says CPU core phase 1 and CPU V core. Oops, didn't do that. That's your phase 1, and this is your CPU V core SO CPU at PH1. You know, whatever that is. And it has something to do with your CPU, and then it's a V core. It's your voltage to your CPU. So something is shorted to ground. So what we're going to do, looks like this goes right to this chip here, which is going to be also your GPU V core and your CPU V core going through that chip. So let's just connect the power up again and see where we're getting hot, and I'll show you how to do that. A little bit of alcohol, a rubbing alcohol, and we're going to connect the power to the board. Take that off. Alright, connecting power to the board. And yep, it's getting hot. Okay, let's see which chip is exactly getting hot. Well, I'm going to take alcohol and I'm going to put some on a microfiber cloth, quite a bit, because we want it to show here. Aha! You see that? See where it's bubbling? That chip we were looking at is bubbling like crazy, so that thing is getting boiling hot. And that's why I just burned myself when I touched it. It's actually popping. Okay, so we're going to remove that and see if we lose our short to ground. You can see over here too, yeah, the CPU is getting hot as well. Oh, that could be bad news. I hope not. Usually, I mean, if your CPU is getting that hot, yeah, it's getting really hot. If it's getting that hot, our CPU may be damaged as well, which is not good news, because we're not going to replace the CPU on this board. So let's go ahead and remove that V-core chip, I guess is what it's called. Let's look it up on the schematics and see what it's called. It's the U7210. Let me get the schematics pulled up. U7210. Yeah, GPU V-core. Alright, let me show you that real quick. Alright, so the U7210 And you can see down here it says CPU V-Core. So that's our V-Core chip. And so that, as you can see, also has a ground lead to it right here. This is this little symbol right here, the little triangle with lines, that is your ground. That's what that means. And you can also see here, right here, it says G&D, 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 that's ground. So either this chip has been shorted internally and it's shorting the ground, or something's going on. So what we're going to do anyways, we're going to remove that that chip and see if we lose our short to ground. I'm going to aim away from the CPU. Let's angle it this way, so when I heat it up, it's not pointing at the CPU. It's funny too, just real quick, you can see on this chip, let's see if I can point that out. Let me zoom in. You see the solder ball over here? That's an indication that it's been overheated as well, or shorted out. And when you have solder balls coming out the side of the chip, that's typically a sign that it's been overheated or shorted. So that's another sign, telltale sign you can look for. Get back in focus here. Alright, let's remove that chip. Funny. See how the solder on this pad right here, it didn't actually flow or didn't melt. And that's typically a sign that that's shorted to ground. So hopefully it's this chip. Let's check it out. Let me get you back on the view where you can see the multimeter. Alright, let's check the same way we did before. We're going to check it right on that coil. Red on ground. So we're still shorted to ground. That's definitely shorted to ground now. Just gonna look around at these capacitors and see if any are short to ground on both sides, or are ground on both sides. None of those are. That's kind of bad news. See, yeah, that's shorted to ground. Let's see, all these are. Okay. Well, let's plug in the power again and see, you know, what we get when we plug in our power adapter. Get back to the camera view. There you go. We have 19.8 volts, 0.32 amps. And that CPU is just blistering hot. Man. Well, that could be bad news. Let's drop some alcohol on this again, just see if we can see anything bubbling up. No, not like it was. CPU is hot. Try it one more time, see what kind of voltage we get. .8 volts, 0.31 amps. Actually, the CPU doesn't seem to be getting that hot. Maybe it was just because I just used the hot air gun on it. It's still hot. Yeah, it's not. I can hold my hand on it. Okay, well, let's check it one more time with the multimeter. I mean, that's still very low resistance. Alright, I have another board like it. Let's see what we're getting on those. It's a very low resistance, which I think the CPU V core is going to get very low resistance anyways. Well, let's do this. Let's try replacing that chip now with this scrap board here, and see if we get the power on. So I'm going to move you over to the microscope view again, and I'm going to go ahead and clean up these pads here and get it ready to replace. Let's put some flux on the board. Touch those pads up. Alright, now we're going to remove the chip from this board and just move it over. Let's see. This. Over to the board here. Put some more flux on it. Lost the coil, it's burned me. coil over. Alright, we're going to cool this off with some alcohol. Kind of cool the whole board down here so we can, feel comfortable turning it on, getting power to the board. Okay, the board's pretty cooled off. How did that come off? That's the keyboard, the top case Flex connector. I'll save that. No telling. Okay. So we're going to connect the power to the board again. So we're getting 0.32 amps. I mean, that chip is no longer overheating, which is good news. Here's what I'm going to do. I'm going to take a display and see if we get any display on it. Let's see. So let's go ahead and plug in the power now. See what we get. No display. Okay. So here's what I'm going to do. At this point, I'm going to examine the board under the microscope one more time. If we see any other damage, we'll go ahead and replace it. If we don't, we're just going to drop it in the ultrasonic, give it a nice good bath, make sure underneath the GPU chip is really clean, and we're going to give it another go and see what we get. So be right back. Let's look under the microscope really quick before we do anything with the ultrasonic. Let's examine the whole board here. Start over here. That has a lot of flux around it. Not sure why. Shows that. At least that's your actual GPU V-Core power chip. It has a lot of flux around it. I mean, yeah. Maybe it's just because that's where I was working at. On this side of the board is where I replaced this chip. I left some solder balls there too. Okay. So that's something to keep an eye on. Let's look at the other side. Let's just glue that was in there from the manufacturer. Oh, this is Flux from where I was replacing that chip. Okay, what I'm going to do, since it looks like mainly it's just Flux is on the chips, I'm going to drop this into the ultrasonic, give it a nice good bath, and see if we can figure out what's going on. So I'm going to do that. Be right back in a few minutes. Okay, so I now have the board out of the ultrasonic cleaner, and we're going to look at it under the microscope one more time and see how it looks. And that residue that's left over, well, that's from the alcohol that I use. It's just residue, typical normal residue that's left over with the alcohol. It's nothing that's corrosive. It's nothing that's going to cause any shortage, short to ground, or any bridging. All the flux is, as you can see, cleaned up pretty nicely from where it was. Everything looks clean and good. Alright, so here's what we're going to do. We're going to take it, we're going to plug it back in, and we're going to see if we get any display on this. And let's hope that we do, because that would be nice to recover this guy's data. Plug in the power. Power to it, 19.8 volts, 0.31 amps. No display. Yeah, unfortunately this is not going to be repairable, and I'll explain to you the reason why. Thinking about his symptoms that he was having when he sent it in to us, and how hot it was getting. Here's the CPU, and here's the chip I replaced. It's really close, and that is the GPU V-Core chip, which was overheating, which was causing the CPU to also overheat. Let's just recall what he mentioned here in his paper. He said that he shut it, put it to sleep, connected it to the power, came back a few hours later, and it was extremely hot. Now he's talking about through the casing. The entire bottom case was very hot. Said he immediately unplugged the adapter, but by that time it's been 2 hours with this extreme heat on this board. And then, yeah, he was just getting no life out of it. Now, considering that it was that same way when I plugged it in and how hot it was, it literally left a mark on my finger because that chip was so hot. With this being that hot and for 2 hours sitting there, unfortunately his CPU is gone. There's nothing I can do about that. So this board is not going to be repairable. Well, our first one of the channel. Non-repairable board. And so unfortunately we're going to have to let this customer know that, you know, the data is not recoverable and his board's not repairable. But anyways, on a sad note, we're going to have to end it there. This does happen from time to time when the CPU on these go bad, which is going to happen. We've gotten quite a few of these boards in and the CPUs ended up being bad. And the reason why is if you're using this type of machine, your 12-inch MacBook, to do very intensive work such as video editing, photo editing, playing, you know, video games, it's not designed for that. It's not designed to do very labor-intensive work. Not designed to run your GPU, your CPU. And the reason is why is because there's no fan in this unit. There's nothing to cool it off. It's not designed for that. So again, this board is bad, so we're going to let the customer know, and we'll move on to the next one. Hopefully soon I'll get some more videos up for you so you can see some repairable videos, and hopefully they match the symptoms that you're having with your unit, so that you can get an idea on what's going on, and we can give you some suggestions on how to fix it, or you can send it to us to fix it, and we can get everything squared away for you. Anyways, that's it for today. Hope you have a great one, and we'll talk to you later.